Okay, I did a Siemens one, and now I want to do a Allen Bradley one. So this is Studio 5000, and what you see is on the left-hand side, you basically see the configuration, um, back plane, and all the cards that are attached to the back plane. In the Siemens, you see the CPU, and there are no cards. It's a standalone. It's more of a brick, so you probably would see additional hardware if there was any cards. Allen Bradley, uh, we have to add cards to have real world inputs and outputs, because slot 0 here is nothing but a processor. And so controller tags and local tags. I have not personally worked with it a lot, but the best answer I have heard on that is local tags are for programs, um, programs like if you're going to have 10 programs, the same program on 10 different machines, and you would then want to use local tags. That way you could have the same program with the same tags in each of the machines. That would make things easier from a troubleshooting standpoint. A controller tag, now, if you wanted to share information between those two machines, then you'd have to have a unique identifier, and that could be then a controller tag. So it could be a unique identifier. Now, if you've got a lot of information to share, then you would come up with controller tags that are like machine 1, this tag, and machine 2, this tag. And then you could do it all with controller tags and get to everything from every machine, but it might be a little harder to do. The other thing about program tags is something local to the PLC that only controls within the PLC. You don't want to share. That's sort of the reasoning behind the 2 points. You can, if you use controller tags, you can get to it. If you use local tags, I think you can actually share those to an HMI. Anyway, that's the best explanation I got, having not worked with it, seen a clear-cut example. You can probably find a discussion online about it. Main routine, and we'll look at the tags here in a minute. But I will show you the main routine. Now, Siemens was opening all the things I had opened down on the bottom, and I think it's still there. Yeah, down here on the bottom, everything I opened was there. And Allen Bradley, it's on the top. Same idea, different thing. Now, the main routine is this is just a stoplight. And so in the stoplight, I have my cycle is either on or off based on whether I'm doing a normal cycle or something else. And I don't remember how detailed I got in this. This is just an example. It's a good programming example, because what you want to do is write a program, get used to the tags, and then associate them with hardware, or alias them with hardware. And then some tags you don't, like this cycle tag. It's just a memory location. Now, in Click, when you open your address picker, you see that all your memory types are here, and then you've got 900 possible outputs. You've got 2000 control or coil bits, which will be virtual. You've got up to 900 real world inputs. Depending on, you'd have to have a rack. You'd have to have a card with that many inputs. Okay, and Allen Bradley and Siemens years ago deemed this was just not necessary. that people needed the flexibility to go in and make them what they wanted to. So timers, counters, and forgot what that was. Oh, system coil or system relays. And then we get into words. So everything was there. Everything was there. Okay. Address picker, everything's defined. Come over to the Siemens. Not Siemens, but the Allen Bradley. And your tags are, you define them. So for my stoplight program, now these top three are examples of what you can do. And so I created just a B bit like you would use in an older Allen Bradley. It's a Boolean, it's a point, it's on off. I created an array called array 1 that has 32 points. And if I extend it down, you see that I'm array 1, bit 0, bit 1, bit 2, etc. And there's 32 of them, so I can make them all in 1 point. And then I did a two-dimensional array where I've got 0, 1 through 8, and then 1 through 1, 0 through 1, 8, then 2, 0 through 2, 8. So that gives me 16 points in a X and a Y data location. And you can do that. Some programmers will do that. And then they'll go back and they'll put in the description of what that point is for or what they're doing. I'm tending toward create tags as you need them because it's easy to do and it's easier then to keep track of them. If you've got a big project, you know you got a lot of tags, then maybe doing it ahead of time, sometimes the best way to go. The nice thing about it when you create like a counter 1 tag, so I'm selecting counter, and this is optional. So there's counter, and all you have to do is type in the data type and it'll come up. When this counter was created, it created these subtags. So I've got a preset and accumulated value for my counter, and then I've got the bits for it. Count up, count down, done, overvalue, and underflow, or overflow and underflow. So I needed 2 counters. I just created a counter 1, a counter 2 tag. I needed a cycle. I needed a straight Boolean tag. Tell me if my cycle was on or off. And so I created that. And then I went down left green, left red, left yellow. I created tags to make them work. And not sure what happened, but they didn't alias, or I didn't alias them right. So then I had to redo it. So this is left green real. So, oh, I know what I did. The left green is for the HMI. So this displays on the HMI. And then I created a tag for the actual output coming off a relay output card if I wanted to use it. That's what I did. So then I aliased it based on that. Also on your tags, all your hardware is going to show up. So there's your slot 1, slot 2, slot 3, slot 4. And so you've got stuff there. And you can go in and put in descriptions and you can use them. Or you can go in and use them as an alias. So I'm taking a tag here that's easy for me to do, and I'm aliasing it back to the actual physical point in the program. What's the difference? Well, I'm glad you had that question. What's the difference? If I go back to my main program, there's my cycle. Everything's taken care of. If I go to a click program and I want a cycle, what I would have to do is go in here and say, okay, and well, I think what I do is use C20. So this is going to be my cycle light. And then when I use it in the program, cycle will show up and it's associated with this memory location. And that's the big difference. Older PLCs, you have something like this. You have everything listed, all the memories defined. Newer PLCs, they'll let you define the memory as you wish. So that's the biggest change. But when you do select a tag, then what you see is it just comes up. The tag just comes up. You don't have to worry about the addressing. So if you're doing tag based and you want to alias things later, you can do that. You can go through and make sure your logic is good. So if somebody's wiring it while you're doing the programming, then you can work out your logic. You can make sure everything's right, and then just go in. All you got to do is alias it correctly to the right points, and there you go. So yes, so my left green, I've got a left green coming on and a left green reel coming on. And so it's actually looking at the tag on the HMI. You probably can get by with one. This was an add-on later. I maybe could have gone in and done that as this alias to this real data point and also used it in the HMI. Not 100% sure. Main routine, if I want more, I can add a subroutine. And when I add a subroutine, I can go in and select what type of subroutine I want to add. Ladder, sequential, and function block diagram structure text. In Studio5000, this is here. Siemens has it, but they don't have it in their TIA. They just do the function block diagram in ladder. So they don't have the sequential function chart, and they don't have structured text in their TIA software. They do have it in their Step 7 software. So see, there's little things about the programming that's not quite all there, not quite all functional, but these companies are competing and trying to stay ahead of each other. They say Allen Bradley was ahead, but Siemens is only, a month or so behind. So as a new feature is asked for, they incorporate it, they put out a new version, and they try and stay as cutting edge as possible. And this would be for advanced programmers who are going into areas that as a beginner and even an intermediate programmer, you hadn't even thought about yet. But once you get the basics down and you can do it, then you're in good shape. I'm not going to create a routine. I will tell you that if you go to the main routine and you look at its properties, it is in ladder. If you create a ladder, you cannot change it to anything else. And the main routine in an Allen Bradley is always going to be in a ladder format. If you create a subroutine, you can create it in whatever format you want, but then you can't go back and change it. Siemens, when I showed you earlier, was you could go in and you could change the language of the program to whatever was available. There was only two: function block diagram and ladder. And it would go ahead and convert it for you. Allen Bradley won't do that. Or if it will, they probably won't tell you it won't do it, but they'll probably tell you there's probably a way. Because they're not going to tell you their software won't do what another software says. Okay. So if I cancel, I'm back to my main routine. If you're going to do a lot of programming, and then you have to set up your processor, you've got to get that processor right, just like Allen Bradley. You select the processor first. If you've got modules on the processors like we do on the Allen Bradley, control logics and compact logics, then you can go online and you can discover it. Once you get that set up, then you can save that as a template if you're always going to be programming the same hardware configuration. And that way you don't have to discover every time. One thing I've noticed about discovering modules is you need to look very carefully when you're online to see if you see a little yellow triangle that is warning you that there's some kind of mismatch. So you'll see the card, you'll see it in the tag list, you'll be able to alias to it, but if you see a little yellow warning triangle, then it probably will not work correctly, if at all. So that's one of the little things you got to sort of look for. And it may mean you don't have the right revision number in your software as the revision number of the actual hardware device. It could be as simple as a mismatch there, but it will not, it will make it not work. You'll see it, it'll look good, you'll be able to download, you'll be able to go online, but it just won't work. And so that's one of the things that has gotten me before, so I'm sharing it with you. Program controllers, local tags, we're in good shape. What you don't see on the Siemens is you don't see the HMI. So if I do file and I do open and I am in the Studio 5000 side, I can go over here, if that'll go away, do the drop down and do view designer. And so from the Studio 5000, if I have a panel out there, I can open it. Rather than wait for it to open, I've already got it open. And that's why I created the second icon on the desktop. Here's my panel. So I've got a button. I've got a text on the middle of the button because I put text on the middle of the button. I identify the button because there might be a way to put text in the middle of the button, but I couldn't figure it out. So basically it's one thing sitting on top of another thing. So there's the button. There's the text. Okay. When I select the button, then I can select its fill color. That's how I made it green. And then I made it a lighter green when it's pressed, and it will go to a lighter green. And I'm setting the tag that's associated with it to a 1 on press and a 0 on release. And it's the newest start push button. So it's coming off the HMI, and I've got a stop, and I've got a start button on the HMI. I also have a hardwired one. And then I've got to make everything work. And that's what my main focus on the class is. Make sure you can get to the PLC on the network. Make sure the HMI and the PLC talk across the network to each other, and then do simple programs where you can do something on the HMI and the PLC will react to it and update the HMI or in some fashion. If I go back to the program, my stop start, stop start, I didn't add it. This is not this is not the newest program in there because we actually added it. We had 2 stop buttons. We had the local hardwired one, and then we had the one from the HMI, and I actually had a start button on here. To do it. Programs change, and if you change it in one place, you got to make sure you change it in another place. The reason we added counters was to count cycles. So I would count normal cycles, and when the normal cycle got to a certain count, we would go to a blink cycle. When the blink cycle got to a certain count, it would go back to a normal cycle, and then we could change the set point of those counts. That was just something we added just to interface, just to get used to using counters. And just interfacing. And that's the type of thing we need to be doing in this class. Just go back to a simple stoplight program, write it down in Bradley, you did it in Click, figure out those differences, and then make it interface with the HMI. You can use 3 lights here. You can use the display here for the stoplight, and if I click on it, I think it shows up. Yeah, so I've got different traffic light modules in the Graphics Explorer. So I've got something that looks like a traffic light. That's where we're at. The HMI software is got tremendous amounts of options. So you've got the properties, you got the animations, what's going to change, and then you've got events. So if it's a push button, you would add an event. How do you want it to press? What do you want it to do? So if I go back to this one and I look at the event, it toggles tag on release. So when I press and release it, I'm basically making that a toggle switch or a selector switch. So this one changes states. Well, what's it associated with? Okay. Newest selector PB. So there's the tag that it is toggling, if you will. Every time you press it, it will, every time you press and release it, it will toggle because that's the way it's set up. And does it change colors? Yeah, when it's a 1, it will be, when you press it, it will go white, and when you release it, it will go back blue. That way you know you've pushed it. And properties, my fill color, something I selected. I think that's all I did there. Anyway, a lot of options. You're only going to have to do 1 or 2. When you get good with one screen, you can add screens, both in the Siemens, both in the Allen Bradley, both in, and also in the Click. These HMIs, you can have multiple screens, and then you've got to set up how do you go from one screen to another. So the first time you add a second screen, just be able to go back and forth. You can usually put a button down here at the bottom, or if some of the screens have the little F buttons, and sometimes you can set those up to go back and forth. You've got lots of options. You're trying to figure out one, and then you go from there. Anyway, I hope this was helpful. And as you learn the little things of the software, you will get there. Stop recording.